This is the section 1.3 vocabulary. Just as a reminder, you can always rewind and always pause when needed as you're recording these vocabulary words as we go through these. Again, these are for the section 1.3 vocabulary. And let's take a look here at the first word. First word for section 1.3 is coordinates of a point. Now, as we go through and we read this, it says here the coordinate of a point is its distance and direction from the origin of a number line. So you have two different things here. You have a number line and you have a coordinate plane. Let's first talk about the number line. The coordinates are much easier to figure out on a number line, obviously, because there's just one line here. You see point P, and the coordinate of point P is -3. In other words, where is that dot at? What number represents that dot? And in this case, it's -3. Okay. The coordinates of a point on a coordinate plane are in the form of x, y. There's always two numbers, where x is the x coordinate and y is the y coordinate. So you'll see here on this example here that you have a coordinate plane. Remember the x-axis, if you remember from Algebra 1, the x-axis is the one that goes from left to right. The y-axis is the one that goes up and down. And as we write coordinate points, it's always x first and y second. However far right or left we went, and then however far up or down we went, depending on obviously whether it's up, down, right, or left. So as you look at this point here in this example, this is our dot, and we want to know how far from the origin it is. Well, in this case, you can see they went left 1, 2, 3, and 4. So left 4 is the first coordinate. The blue one here, that's on the x-axis. That would go here where the x value is. So we go left 4, that's -4. And then we go up 3. We go up 1, up 2, and up 3. That's the y coordinate, in this case, up 3. So the actual coordinate of point T is the ordered pair -4 and 3. And you can see the difference between a number line and a coordinate plane. Second word here is the distance between 2 points on a line. Okay, it says here the distance between 2 points on a line is the absolute value of the difference of the coordinates of the points. Now there's some key vocabulary words here that you've seen in the past. Difference means to subtract. Okay, absolute value talks about how far a number is away from 0. In other words, it's usually always going to make the number positive. So as you see over here on the right side in this picture, we have point A and point B. Those are by the capital letters, and these little letters down here are the actual coordinates of it. Okay, so what they've done is to figure out the distance from A to B, you take the coordinate of A, subtract the coordinate of B, and take the absolute value. Because again, as we always talk, distance will always be a positive number. Okay, so let's kind of, for example here, let's take a look at this and let's see here. If this was 5 and that was 9, I would take 5 minus 9 and take the absolute value. So 5 minus 9 is -4. And the absolute value of -4, how far is -4 away from 0? It's 4 units. So it's 4 units to get from 5 to 9. Okay, third word is the distance from a point to a line. Okay, we don't talk about this a ton, but I wanted to put this in here to kind of discuss it a little bit. It says here the distance from a point to a line is the length of the perpendicular segment from the point to the line. Now, we haven't really talked about perpendicular. We're going to talk about that here in a second. But perpendicular means two lines intersect to form a right angle. And you can see that here. So essentially what they're asking for is how far of a distance is it from this point P to the line? Okay. And you'll notice they put a point T in here where the lines intersect. Well, the distance simply is from point P to the line is from P to T. That's how far it is. That's how long it is. Okay, congruent segments. Congruent segments essentially are segments that have the same length. They're two congruent segments are essentially two segments that are equal. It's very similar to that. But you'll notice, as you see here in the symbol, the congruent symbol is an equal sign with a little squiggly line up top. That's the congruent symbol. It's slightly different when we start talking about things. They mean the same thing, but they represent two different things. You'll notice here that we can say that these two are congruent because we know that this is 2 centimeters, CD is 2 centimeters, and we know that AB is 2 centimeters. Congruent segments, two segments that have the same length. The midpoint of a segment. The midpoint of a segment is the point that divides the segment into two congruent segments. So, as you see over here in the picture, you have point A, you have point B, and you see M. M is the midpoint because essentially it cuts those 2 points in half. Okay? So, in other words, from A to M is the same distance as from M to B. It cuts it in half, cuts it into two congruent segments. That's the midpoint. A segment bisector. When you bisect something, and again, this is something you might want to write down in your vocabulary as well. When you bisect something, you cut something into two equal parts. That's what bisect means. A segment bisector is a line that cuts a line into two equal parts. So a segment bisector is a line, segment, or ray, or it could be a plane for that matter, that intersects a segment at its midpoint. Okay? So, as you see here, you have line L here. This is the bisector. KJ is another segment. This line L bisects KJ because, as you see in this little spot right here in the middle, right here, where they intersect, it's the halfway point, or it's the point that makes from K to this dot the same distance as from the dot to J. So in other words, it cuts it exactly in half. That's a segment bisector. I told you there was going to be a couple words here that we're going to add into section 1.3. These are in your packet as well, but these come from a different section. Perpendicular lines. This is something that we're going to look at a lot. We're going to use a lot throughout the year. Perpendicular lines are lines that intersect to form right angles. So two lines that cross and they form a right angle. How do you tell that it's a right angle? Okay, most of you already probably know this, but when you put a little box here in the corner, that means that that's a right angle, and a right angle is 90 degrees. Okay, the symbol, it's an upside down T, is perpendicular to. So again, the upside down T, that means is perpendicular. When you see that, you're going to see that symbol a lot as we go through here. Okay, so in this case, N and M intersect, and they intersect to form a right angle, so M is perpendicular to N. Okay, so now we're going to take those two words and put them together, perpendicular and bisector. So if two lines are perpendicular, okay, they form a right angle, they intersect to form a right angle, and if it's a perpendicular bisector, they intersect to cut one of those lines in two equal parts. So the perpendicular bisector of a segment is a line, segment or ray, that is perpendicular to the segment at its midpoint. So let's start with line AB. Here's line AB right here. Okay, and then you have line MY, or line Z in this case. Okay, or line YZ. M is in the middle here. Okay, so M is in the middle. As I mark this down here, right there's point M. Okay, so what happens here is line YZ is perpendicular to line AB because it's a right angle. You see the little box there. That's the perpendicular part. It's also a perpendicular bisector because it cuts line AB into two equal parts, or it cuts it in half. So from A to M is the same length as M to B. Okay? Or as it says here, YZ is the perpendicular bisector of AB. It's perpendicular to line AB, and it intersects AB at its midpoint, which is point M. Okay, this concludes section 1.3 vocabulary. Make sure you have these written down in your vocabulary packet. And again, a reminder, you can always rewind and pause whenever you need to.